Okay, now moving on to the second part of this question, part B. You can already see it's a star marked question, asterisk mark is here. And well, the questions marked with asterisks, they are a bit different from the rest. They're different because in these questions, your answer must be coherent, or it must be on track. It must be logically well structured, and there must be linkages between your explanations or your sentences. Linkage means that we cannot just skip out any steps, or you cannot just like you're writing step 1 and step 2 and then you skip to step 4. No, you can't do that. You must maintain the chronological order 1, 2, 3, 4, 5, and there must be a proper connection between your points as you're writing down them one after another. Okay, and finally, you must have full reasoning with your points. You must show the reason. You must explain clearly. So I will just quickly jot them out for you over here. So for any asterisk question, the things that you need to keep in mind. Number one, coherent, must be coherent, which means on track. Secondly, logically well structured. Thirdly, must have linkages, so contain linkage or connections. And finally, contains full reasoning. These are the 4 things you need to keep in mind while answering any asterisk marked question. And the examiners will always look out for these 4 criteria in your answer, plus your points, of course. The points are the main thing here, but if you don't have this, you will not get the full 6 mark here. You'll lose marks definitely. All right, so with that being said, let's read the question now. Okay, the answer to part A did not consider the effect of air resistance. So yeah, we already have seen that the question we just solved earlier in part A, the air resistance was ignored, so we could easily use the value for acceleration is negative 9.81. The only thing acting there was weight, but now if there is air resistance, weight is not the only thing here. There is also a second force acting on the projectile, that is air resistance. So yeah, weight plus air resistance. Okay. All right. The trajectories of the motion of the ball with air resistance and without air resistance are shown. So you have the trajectories shown here. The dotted line here is the one without air resistance, the one we usually always see without any air resistance. And then the solid line below is the one with air resistance. Explain the differences between the two paths. Okay, so we just have to point out the differences and explain them with the 4 criteria. It must be coherent, logically structured, with linkages, and full reasoning. So the question seems fairly simple, but explaining it in the most logical style is not what we are always able to do. So let's see how to do it. Just observe the 2 paths here. We have 2 paths, one with and without air resistance. The one without air resistance has a higher max height, and the one with air resistance has a lower max height. So we have got the first difference here. Second difference is that the one without air resistance has a greater range or greater horizontal displacement than the one with air resistance. That's the second difference point. We have got 2 differences so far. And believe me or not, these are the only 2 things you need. So you might be wondering how to get the 6 marks out of these 2 points only. You'll see that shortly. So before that, there are 2 top tips for you. Always remember them for projectile motions, especially questions like this. Okay, top tips. Top tip number 1. Okay, the max height of the projectile depends on the vertical velocity. Depends on the vertical velocity. Range depends on the horizontal velocity. Okay, so if the vertical velocity changes, the max height will change. If the horizontal velocity changes, the range will change. Max height and range. These are the only two things that are different between these two trajectories, max height and range. One is higher, one is lower. The one with air resistance has both of it lower. Okay, the max height is less, and the range is also less for the projectile with air resistance. So we can already see what might be the key factor here. The components of velocity, vertical component, and the horizontal component. These are the two components of velocity every time that will change your max height and range. Alright, so now we can jump onto the answer, given that you have understood the topic here. So we're gonna write the answer for the trajectory with air resistance. Alright, we are gonna break down the answer into two sections. So one section, each section is for one component. So the first section will be for the vertical motion, and the second part will be for the horizontal. So the first point we can write here for the vertical motion is that when the ball is moving up, we have two forces acting here. Okay, we have two forces acting here. So I'm going to explain it to you very clearly. Say this is the ball, this is its path, like this, and then when it's here, we usually will have only the weight acting on the ball. But now we just don't have the weight, we also have something else, which is air resistance. So weight plus air resistance. Weight plus air resistance combined, these two will have a greater resultant force acting downwards. So the resultant force now is greater due to the air resistance, which is also acting downwards. And if the force is acting downwards from Newton's second law, the acceleration will be also downwards. Plus it's negative because downward is negative. So we already have a negative g acting downwards. Now we also have something more negative. Now which means something with a greater deceleration acting downwards. And this greater deceleration will pull the ball even more downwards, making the max height smaller. Okay, there's a greater pull downwards now, uh, reducing the max height. So this is what is happening for the vertical motion. Just this air resistance bringing the ball down. Okay, so now let's move on to the answer. So when the ball is moving up, weight, we can also write both weight and air resistance act on the ball. So the first thing to mention here is this. So if this happens, this increase because now it's greater, this increased force means that the downward resultant force is now greater as expected. So if the downward resultant force is greater, there will be a greater deceleration. So the greater the force, the greater the deceleration downwards. So this means that the the decelerate. We can write it this way. This means that the ball decelerates more, uh, downwards. This means that the ball decelerates more downwards. Uh, so the vertical velocity is the vertical velocity reduces. All right. So since the deceleration is greater, velocity will reduce even more, reduces more quickly. Okay, so we know deceleration means a decrease in speed. So if the deceleration is greater, the vertical velocity reduces more quickly, which is a greater rate of change of velocity. So velocity changes shorter time if the deceleration is greater. All right, so that was all for the vertical motion. Oh, we just need to add one more thing here. That is, if the velocity reduces quickly, so hence the ball reaches lower maximum height. Okay, which just have seen that before. If the vertical velocity is less, max height will be less. This exactly just happened here. The ball reaches a lower maximum height because the vertical velocity reduces. It is now less. So that was all for the vertical motion. Now for the horizontal motion, we also have an air resistance here acting as well. So let me draw that again. So this is the vertical not vertical, the horizontal component of velocity. This is the horizontal velocity, which is always constant, we know, because there is no uh, acceleration acting horizontally. So this was always constant. But now, if we consider air resistance here as well, air resistance will oppose this horizontal force and it will bring it down. So this will no longer be constant. It will reduce to this size. It will be lower than before. So that is all due to the air resistance. It is simply opposing the horizontal force of the ball. So just can write exactly that. Uh, the air resistance acts on the ball horizontally. Specify that opposing the motion. Second, if it happens like that, uh, the net horizontal velocity, or you can also write the average horizontal velocity, the resultant horizontal velocity, whatever you can like, the same. The net horizontal velocity reduces. So if the horizontal velocity is now less, we have seen that if the horizontal velocity is less, the range will be less. So the ball travels a shorter distance before landing. So this is the final answer for this question. So for a quick review, you must know the top tips here. If the vertical velocity changes, the max height will change. If the horizontal velocity changes, the range of the projectile will change. And here we have to explain the difference between the two paths, max height and range. These were the only two differences here between the two trajectories. We just have to explain in terms of them, but you must know how they change. It's all because of the two components of the velocity. Remember the components here. Okay. So for the vertical part, here, weight was not the only thing. It was weight plus air resistance. So greater downward resultant force, greater acceleration. And so the ball is pulled even more downwards, reducing the max height. And for the horizontal motion, we have air resistance opposing the ball horizontally, which in turn reduces the average horizontal velocity. It reduces, hence the ball will travel shorter distance before landing. So that was all for this question. It was uh, a very unique question for projectile motion. So make sure to have your concept and your content points really clear inside your head. And with that being said, best wishes for your exams. Thank you for watching.